3117. Which other ones that you guys want to see? 18. All right. So going through some of these for you guys. 31 says use synthetic division to put, in order to put the fraction in the form q of x plus r of x over d of x, where 31 is so Caitlin, when you look at this, what's the issue?
The leading coefficient is not 1.
Yeah, so if you look at this, the divisor doesn't have a leading coefficient of 1, right? Okay, that seems like it's a problem.
You just divide it.
It's not too bad. If I take this and I still set it equal to 0 and solve, I get 1/2. So I'm going to use 1/2 to do my synthetic division with. Now there's still some more to deal with when we get done. We're not quite finished when we do that, but we do. That is how we're going to start. So what numbers go along here to start?
2, -2, 0, -5, 7, 1.
Good. Yeah. Is there synthetic division on the ACT?
Yeah.
I haven't looked at ACT questions in long enough to be able to answer that. Seniors that have recently taken the ACT, did you encounter any synthetic division?
I don't think you can do it.
I think it's more of a guessing game.
You can take the ACT without doing any math.
That happened a lot for me.
You can do a lot of things, I guess. It really is. ACT sucks.
I think that's right. That's me trying to mental math that divisions. Okay. So we did our synthetic division here, right? But we still there's a little bit of cleanup to do here before we can get it to that form. So what did this tell us? This told us that 2x squared minus 5x squared plus 7x plus 1 is equal to x minus 1/2 times, let's see, remainder constant x squared, x to the third. Everybody's okay here. Okay. So if I divide both sides by x minus 1/2, I get this. And again, I'm working this out carefully so you can understand like the reasoning going on here. These are not all necessary steps per se. Okay. So this is close, but the issue is that my denominator here isn't what it required in the first step, right? If I go back to the very first step, not the same denominator. Everybody's okay there? So what I'm going to do is I'm going to multiply both sides of this equation by 1 over 2. When I do that, that 2 is going to distribute, and I'm going to get what I need on the denominator. There, right? And then that 1/2 is going to distribute all over there and to this one. So that's going to give me x cubed plus, I'll just use decimals since I've been using decimals. So there's, I believe, my answer. Let's double check that. That's a mistake. Yeah, that's wrong. So the answer key is wrong in this regard. This one is correct. We forgot to divide by 2.
So why did you just end it with?
So the reason is that it's not in the correct form because we want this to equal to say that, right? What we're doing here, though, when we did this synthetic division, isn't that. What we did was we did this division.
So how do you, how do you know it really? Does this always happen?
Only when we had a leading coefficient in our divisor that wasn't 1. That's the issue here. That's why we're having problems. Why we had to do all this additional work. But if you look at things quickly, if I take the polynomial part here and I take the polynomial part here, how are those two related? It's divided by 2, right? Which is what we did when we translated that into a form that we could do the synthetic division with. So whatever I divided by up there, I can just divide by just those outputs, not the remainder, from my synthetic division, and that's really all I need. But I want to explain to you like why we're having to do that by kind of grinding the whole thing out. Caitlin, does that feel a bit better? It's just kind of a pain if the leading coefficient isn't 1 is what it boils down to. We can still kind of handle it, but we got to be sneaky about it. That was probably the most difficult one. So don't get too up in arms. 17 is next, right? Is that, David, you asked for this one? And I'm guessing that I have an idea of what the issue was on this. So this one just asked us to do long division. So when I set up my long division, I'm going to include some zeros here as placeholders everywhere where I'm missing a term. And I do that just because it helps keep everything line up a little bit nicer. So I included a 0 in between the x squared and the 7, and a 0 between the x to the 4th and the x squared, or the 2x squared. So I'm going to ask myself, what times x squared gives me x to the 4th? Well, that's just x squared. So I multiply that x squared by each of those pieces. And then I subtract down. So x to the 4th minus x to the 4th is 0. 0x to the 3rd minus 0x to the 3rd is 0. 2x squared minus 7x squared is negative 5x squared. And then I'll bring the rest of this down. Okay so far, David?
Yeah.
Okay. Now I'll ask myself, what times x squared gives me negative 5x squared? Negative 5. So I'll multiply that to all the pieces. Oops, 35. And then I'll subtract down. So negative 5x minus a negative is the same thing as adding. So negative 5x plus plus 5x is 0, right? And then I have negative 4 minus 0, which is just negative 4x. And then 1 minus a negative 36 is positive, or sorry, minus a negative 35 is positive 36. And then what times x squared gives me negative 4x? Not a polynomial, right? I would need an x in the denominator, so those don't count. So that's going to be my remainder then. So we're going to write our answer then as x squared minus 5, that's the quotient, plus my remainder over my divisor. How's that, David? That's good. Kendall, you said you wanted to do 18? Is that the next one, I think? So did you put a 0 in there?
No.
So that's probably would help. For these ones, it's not critical, but it just keeps everything lining up correctly so you're not tempted to combine things that aren't like terms, which is very tempting if you don't write the 0 in there to go, oh, I'm going to do x cubed plus x squared and make up some math on how to do that because they happen to line up underneath each other. All right. So this is a pain also because we're going to have a bunch of fractions, but oh well. So what times 2x gives me x cubed? Well, I know the coefficient has to be 1/2 because 1/2 times 2 gives me a coefficient of 1, right? And then it has to be x squared because x squared times x gives me the x cubed. Everybody's okay with that idea? Okay, I'll do that. So it's going to give me x cubed minus 2x squared. And then we'll subtract down to get 2x squared. And then bring down the next piece. And we'll ask ourselves, what times 2x gives me 2x squared? That's just x. So that's going to give me negative 3x. And then I'll bring down that last little part. And then, again, I'm stuck with kind of a crummy fraction to deal with, right? So what times 2x gives me negative 3x? That's going to be negative 3 over 2. So multiply that to both places. Plus 6. And that gives me negative 5 as my remainder. So my answer I'd write is 1/2 x squared plus x minus 3 over 2 plus negative 5 over 2x minus 4. Is that okay, Kendall? Just kind of a pain to deal with the fractions and stuff in there, right? Danny?
So you multiply 4 by x.
Mm-hmm. So you're talking about the 4x that I got right there, right?
Yeah.
When I took this x and multiplied it to the negative 4.
Okay, yeah, I'm good. I wrote that.
Yep, no problem. Just trying to make sure that I understood what part you were talking about. And then I think there was one more, right? What was the last one that somebody had asked about? 28. Again, we can do more if there's still more after this, but this, upon first glance, these were the questions that we had asked. Oh, good. This is synthetic division problem, so it should be pretty quick, as opposed to some of those other ones that were a little lengthy. Okay. So let's set this bad mama jamma up. What's going to go on the outside here? Just the 4, right? Because I said x minus 4 equal to 0, and then I solve it. And what number is going to go across the inside? 2, 0, negative 5, and then 4. What's the 0 there for? The x squareds that aren't in my problem. Yeah. So bring it down. 4 times 2 is 8. I add down, I get 8. 4 times 8 is 32. I add down, I get 27. 4 times 27 is 120, oops. No, 108, excuse me. And I add down, I get 112. So I get 2x squared plus 8x plus 27 plus 112 over x minus 4. You did it as long division. That would have taken a lot more time. I don't know why you would either. I don't know about dumb of you, but like, wasn't the fast way to do it. Danny?
Can I ask you?
Yeah, of course you can.
Could you do 21?
21? Sure. So it says, use the remainder theorem in order to evaluate the specified value of the function. So it says g of 4. So all I'm going to do is put 4 on the outside and do this just like I would a synthetic division problem. So the place where the likely mistake that we made was we went from 3x to the 4th, negative 3x cubed, to 5x. So I want to make sure I put a 0 there for the x squareds. My guess is that we didn't put the 0 in. So then I'll start this up just like I would a synthetic division problem. And the part that gives me my answer is the remainder is going to be the same thing as whatever this function evaluates out to be at 4. You're welcome. Was it the 0?
I set it up wrong.
You set it up wrong? So you just, these substitution problems work just like the synthetic division problem? Yeah. So it's not too bad. They're all kind of doing the same thing, right? Okay. Does everybody feel okay about this procedures? Being able to do these divisions is going to be really important going forward, because as we start trying to factor and solve polynomials, our major tool is going to be synthetic division. So we need to be able to do this process. Factoring and solving polynomials. I don't think it's difficult, but you should know how to do it already. And that's why we reviewed it the last couple of days and why we just went through all these homework problems as examples while you were twiddling your thumbs or doing whatever back there. Then why are you sitting in the back of this class when your desk is at the very front? And your glasses are off. Problem solved. Okay. Are we okay with what's going on here so far? You think so? Okay. I know.
We all know it's going to snow in like 10
10 minutes? I will take the bet on that it will not be snowing in 10 minutes.
No, there's a reason I'm not a betting man.
Wait, can I ask you a question?
Of course.
So if your leading coefficient's not 1, and it's like the 2 problem, like how you divided it by 2.
It's supposed to snow.
We're talking about this problem number 30.
If the leading coefficient's 3, would you just divide your problem by 3? And even at the end, so it's like, well, you divided it.
All right. Yes. Well, the copies were made incorrectly. So like half the questions were gone.
Why are you? I bet they were so.
Were you sad?
I was pretty miffed about it.
Yeah, I bet you were sad.
Yeah, that would have been annoying for you.
Yeah, I was like,
They were probably like, Mr. Cool's the best teacher in the entire world.
no, they were like, oh, it was going so well. Can't I just keep this first? I'm like, no, I'm dealing with any of that. Throw everything away. Just read.
They started it.
Well, somebody asked me halfway through. It's like, why does this go from 3 to 5? And I looked at him like, oh my god, it's all just one-sided.
Why didn't you just, what's it called, make them do those?
Because then we'd have to do again the other half of the questions.
That's fine.
I'm not taking 2 days to burn 2 class days to deal with one test. No, they're going to do it next class when I have the correct copies made, and we just did whatever we're going to do the next class today.
I'm sorry.
You know, it's fine. No, you don't have free time, you goofus.
No, I have a test due.
I mean, you don't test it.
Keep going.
All right, so this is, we're continuing along in whatever this section is, section whatever. What section are we in? 3. Okay. So we're going to start with what's called the rational zeros theorem. Okay, so for a polynomial function, f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1, yada, 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 all the way down to a sub 0. We know that if this function has rational zeros, those rational zeros will be of the form a factor of the constant term divided by a factor of the leading coefficient. Do we know what I mean when I say rational zero? No. Okay. So what I mean there is a zero that is either a fraction or a whole number. Okay? So like 7 would be a rational zero, or 1/3 would be a rational zero, but the square root of 2 would not be, because there's no way to rewrite the square root of 2 as a fraction. Everybody okay with that idea now? So let's say we want to list the possible rational zeros for the function 3x to the 4th plus 4x squared plus 7x minus 4. So to do this, I need to determine the factors of the constant term. So what numbers are factors of 4? Do you guys know what I mean when I say factor? 2 is a factor. There's 2 more. 1 is a factor, and 4 is a factor. These are all the numbers that divide 4 evenly. Okay? The other thing that we care about is we also need the factors of the leading coefficient. What are the factors of 3? 3 and 1. Everybody okay there? So I can use this information now to list the possible rational zeros for this function f of x are. So I'm going to take each of the factors from 4 and divide them by each of the factors of 3. So I would have plus or minus 1 over 1. And then plus or minus 2 over 1. Then plus or minus 4 over 1. Everybody's okay there? Yes, it is. And then I'll do the same thing. I'm going to take 1 over 3. And then 2 over 3. and then 4 over 3. Everybody okay with that idea? Is this chapter like a pain in the butt? Yes. Well, so Gisela, it's an interesting point. You know the reason that it's a pain in the butt? So solving a polynomial equation, when there's one variable, or when the degree is 1, it's very easy, right? That's just a linear equation. It's a piece of cake. When the degree is 2, it's a quadratic. We have a closed form formula, the quadratic formula. It can solve any one of those. That's pretty easy. When it's degree 3, there is a formula to do that. It's pretty terrible. Degree 4, there's a formula, but it's like really pretty terrible, and it's like not closed form, and there's like a bunch of parts to it. Degree 5, it's been proven that it's impossible to create a formula. So degree 5 and higher, there is no formulaic way to solve this. No, it's been proven that it cannot be done. You can't unprove something.
You can disprove it.
Not in mathematics, that's not how that works.
I mean, have you tried?
Don't people like further AP or whatever it is? I don't know. It's one of these classes. It's an API test. Don't they have to like prove like formula or something? Don't they like write a math paper?
Yes. In the IB courses, that's the internal assessment.
Have you finished your dissertation?
No, I've started.
How long do you have?
I mean, it's going to be another year at least.
What's a dissertation?
It's my doctoral thesis.
Isn't it?
Like all your like college work and
No, but it's like a hard problem that I've been working on for a while.
This is for school, is it for yourself?
It's for my graduate school. It's for my doctoral program. Anyways, we're okay with this idea though? So one of the issues with this is now, okay, so if I wanted to try to factor this polynomial, I could check to see if it has any rational factors just by doing synthetic division with each one of these, right? Okay, that'll work, but that's pretty time consuming. One thing I can do is I can eliminate some values from this list by using the bounds theorem. And I don't think that we talked about this in our algebra class. So this says if f of x is a polynomial, with positive leading coefficient, and we divide by x minus k using synthetic division, then if that value for k is greater than or equal to 0, and every number on the, in the bottom line is non-negative. What's the difference between non-negative and positive? Non-negative includes 0. Yeah. Then k is an upper bound for all the real zeros of f So if k is less than or equal to 0, and every number in the bottom line is alternating, non-negative and non-positive, then k is a lower bound for all the real zeros of f. When I use the terms upper bound and lower bound, do you guys know what I mean by that? So the lower bound means that any real zero would have to be, this is the smallest one possible, right? So if my lower bound was 7, well, if it was -3, it means that like -4 couldn't be a 0, or -5 couldn't be a 0, -6 couldn't be a 0. Nothing can be lower than the lower bound. Similarly, the upper bound, if the upper bound was, say, 8, I would know that 9 couldn't be a 0 because the biggest 0 I could have would be 8. Does that make a little bit more sense in terms of what I mean by upper bound and lower bound? Okay. We'll do an example here in a minute, but that was a lot of writing, so I'll give you guys a chance to kind of catch up. So let's do an example here. This example says, show that every real zero of the polynomial f of x equals 6x cubed plus 25x squared plus 16x minus 15 lies within the interval -5, +4. So in other words, what this means is show -5 is a lower bound for the real zeros, and that +4 is an upper bound for the real zeros. That would tell us that all the real zeros need to be between -5 and +4, if I can do that. How do I do this? Well, I do synthetic division using the theorem up above. So I'll take -5 and since this value is negative, I'm hoping when I do the synthetic division, I'm going to see alternating signs. Okay? So far, so good, right? I have a positive, then a negative. I do it again. Got a positive, that's good. And I do it again. And I get a negative. When I say LB there, I'm just abbreviating lower bound. I think I've done that already and not made mention of that, but hopefully that's obvious from context what LB would be. And I'll use UB for upper bound. I mean, we're not doing any, southbound's not a thing, but okay.
Right bound.
Not in math.
What about vector?
I don't think so. Due south would be something. Sure. I don't know if you'd say southbound though.
You shouldn't, but you could.
All right. So that's half of it, right? So what part of the proposition have we shown here? We've shown that -5 is the bottom, right? The other half that we need then is that +4 is the top. So we still need to do the synthetic division now with +4. What are we hoping for, or what are we hoping to happen when we do this synthetic division? We want all the numbers to be non-negative. So let's go ahead and do that. And that's exactly what we saw, right? Since all the numbers under our synthetic division are non-negative, and we divided with a positive number, we know that that number then is our upper bound for the real zeros of f of x. Thus, all the real zeros for f of x lie on the interval -5 to +4. And we're done. Notice that it didn't ask us to solve this, right? Let's do one more example here. Thus. All right, so let's say we want to find all the real zeros for the polynomial f of x equals 6x cubed plus 23x squared minus 83x minus 30. So what I'm going to hope to do is I'm going to make a list of the possible rational zeros, try to find one of those that works via synthetic division. It'll give me a remainder 0, so that I can break this down into a linear term from the synthetic division times a quadratic term, the quotient of that polynomial division, and then I can set each of those equal to 0 and solve, and the quadratic is easy to solve because I can just use the quadratic formula or something on it. Is that okay with that plan? So the first thing I need to do is list my factors of what two numbers? Yeah, good. I don't worry about the signs when I do it because I just put the plus or minuses on at the end. So what are the factors of 30? 2, 3, 5, 6, 10, 15, and 30. What are the factors of 6? Okay. So if I want my possible rational zeros, there's going to be one heck of a list, right? So that's all of the factors of 30 over 1. Notice I didn't write the over 1 because we don't really need to. So now I'm going to write them over 2, but I can skip all the even ones. Why can I skip the even ones? Because if I did 2 over 2, what's that the same as? 1, and 1's already on my list, right? So I'm just going to write down the odd ones over 2, just to save myself some redundancy. Is everybody okay with that? It's okay to write the even ones down over 2, but you should go back and cross them off because you don't need them on the list more than once. Everybody's okay with that? It's tedious for sure. Now we'll do the same thing with everything over 3, but again, I'm going to skip the things that are divisible by 3 because they're already on the list. And then lastly, everything over 6. Again, I'm going to skip the things that reduce here. For example, 2 over 6 reduces down to 1/3, which is already on my list. So I don't have to list all of these things. In fact, I think that's all of them. Everything else reduces, and I have it somewhere else. Okay, so that's my list. So should I just guess and check from here? Which one should I start with? How many things are on that list? 1, 2, 3, 4, 5, 6, 7, 8, 16, 18 times 2. So 36 choices. At worst, only one of them is going to work. You got to remember the plus or minus, though. So each of them is 2. Yeah, so that stinks, right? Guess what we're going to do instead?
Use our calculator.
We're going to take a look at the graph. and see if we can get a hint about where to start. Sound good? Okay. So I just went ahead and typed in my function. I'm going to check the window to make sure it's somewhat reasonable. So -10 to +10 is pretty reasonable. So let's just hit graph, because all I really am looking for are x-intercepts. So how many times do you see this crossing the x-axis? 3, right? So let's see, this one over here, I see +1, +2, somewhere in between +2 and +3, it's crossing. Do we have anything on our list down here that's a decimal in between 2 and 3? Well, 3 over 2 is 1.5. 5 over 2, okay. What else? Is there anything else? 5 over 3 is less than 2. So that could be one of them. Everybody okay? Let's go back and look at some of the other ones. This one is happening in between -1 and 0, it looks like, right? So that could be a -1/2, but it could also be a 1/3 or a 1/6 too. It's not entirely clear just by looking at it which one of those it is. And then the last one over here, let's see, -1, 2, 3, 4, 5, 6 maybe? Yeah, it's -6 is what that looks like to me. If I counted, are you okay with that? So, which one of these do you want to try to do our synthetic division with? Yeah, -6 seems like the best one to start with, right? It's a whole number. That seems like that might be the easiest. So let's try that one. How do I know if this works or not? Yeah, the remainder needs to be 0. Which, boom shakalaka, that's what we got. Boom shakalaka. So what does this tell me then? It tells me that this quadratic is going to factor. One of the pieces is going to come from this. What factor comes from that? X plus 6. Because remember what this is. This is x equals -6. So if I add the 6 to both sides, I have my factor back again. The other factor is going to come from this stuff. What is that factor going to be? Remember, this is remainder, constant x and x squared. We okay there? So since I've got this factor down into linear and quadratic pieces, to find the zeros, I'll just take this function and set it equal to 0. And then I can set each piece equal to 0.